Alright, let's look at the homework 2.4, problem number 4. Alright, so in this video, I'm going to do it by hand. Alright, so remember the definition of this limit. Alright, so we have the definition is, alright, for all epsilon greater than 0, there exists delta, which is greater than 0, such that, right, if the distance between x and a, in this case a is 2, is between 0 and this delta, this will guarantee that the distance between function, which is 5x minus 9, and the limit value is 1, is less than epsilon. Right? So if you work with this and with the conclusion and try to find the expression for delta, so let's do that. So I'm going to start with this guy right here. So we're kind of working backward. All right, so I'm going to just combine negative 9 and negative 1. So you would end up with this. All right, absolute value of 5x minus 10. Right, is less than epsilon. Right, so since 5 is in common, I'm going to pull 5 out, and x minus 2 is less than epsilon. Right, then we notice that this is actually the guy we're interested. See, we have absolute value of x minus 2. So therefore, I'm going to just get rid of 5 by dividing through by 5. So the upper bound of absolute value of x minus 2 is less than epsilon over 5. All right, now we have a formula here. So we're going to let delta equal this, epsilon over 5. All right, so the correct delta value can be found by simply dividing by 5. All right, so which means that if it's a 0.5, then divide by 5, so 0.1. All right, so it's if it's a 0.1, divide by 5, 0.02. If it's a 0.05, then divide by 5, 0.01. All right, so let's plug it in. All right, so we found that 0.1 there, and the 0.02 there, and it's going to be 0.01. All right, so submit for testing. All right, it came back, and I got all three of them correctly. All right, that's it. I hope that this was clear.